Thinking in C, Chapter 4, Controlling Program Flow. Control flow consists of those operators and constructs that allow you to do what we call structured programming. It allows you to structure your programs to express algorithms in a way that is very clean and gets away from the old go-to style of programming that came about with machine coding and assembly language coding and BASIC in the old days. The basic things we'll talk about are decision making, that's the if-else stuff, repetition or looping, and when you have to, yes, there is some sort of go-to, although it's a dreaded and terrible thing, as some people say, you do have that facility in the language. Although structured programming as a term evolved to mean some different things in the late 80s, it originated in the 60s with some research that proved that all algorithms can be expressed in terms of decision-making, looping, in tandem with an arbitrary number of Boolean flags. And so that's really all structured programming is. And the point was to get away from a lot of spaghetti code, which was pretty common in the old days of Fortran and BASIC, go to everywhere. So really all you need is a sequence of statements which is structured via this idea of selection or decision-making and repetition or looping. Well, there was an actual theorem proved to that effect. But most languages will still give you some sort of capability to do some branching. Even if a language doesn't support GoTo, then they support something that's equivalent. Well, GoTo does exist in C and in C++ with well-designed code. It's rarely used, rarely needs to be used. Java doesn't even have the GoTo. Decision-making in C is very similar to the features that are available in other languages. You use the if statement, if, else. And there's also a special type of if statement, which is traditionally called a case statement. We use a different keyword in C for that, but it's where you actually pick from a group of integer values instead of explicitly saying if this, then do this, otherwise do that. The syntax for the if statement is the keyword if, followed by an expression in parentheses, and that expression is evaluated for its truth value. So again, recalling from last chapter, if it's non-zero, it'll be true, and if it's 0, it'll be considered false. And so for non-zero, statement 1 will be executed, otherwise statement 2 will be executed. Now, in place of statement 1 or statement 2, you could have a compound statement, which would be a group of statements surrounded by curly braces. This program illustrates using if and else by reading in a number from the keyboard, assuming that it's your age, and making comments about it. So I have a variable age, an int. I print out a prompt, I read it in, and now I just ask some questions. If age is less than 20, well, then I'll say something about that. You're just a youth. Notice a common mistake is to put a semicolon right after your condition, right after the age less than 20. You shouldn't do that. The semicolon only belongs to a statement, and if is incomplete. It's not a statement by itself. It's a construct. So it's if condition statement, else statement. Notice that I can follow the else with another if, of course. It's just another statement or part of another statement which follows the else. So I say, if age is less than 20, do this. Otherwise, if age is less than 40, do this. Otherwise, and just keep chaining like that. It works the same in most programming languages. And then there's a final clause at the end, which if you enter a number which doesn't fall into any of these categories, then I will actually verify, just for fun. Are you really that old? Because you've put in a number that is 80 or older. Now notice that in this block, in the last else clause, I declare a variable in the beginning of the block. You can do that. Now some people are in the habit of always declaring their variables at the top of the program. But it's a good idea in C, and especially in C++ and Java, to always declare your variables when you need them. In other words, as late as possible. So I'll declare a character variable called really, and I'm going to have you type in an answer to my question. First, I'll print out, are you really that old? Whatever that number was that you typed. And then I'll read in a single character. %C is the format specifier for a single character. So, also notice that I have a space before the %C. That's just in case you typed a space accidentally. You see, the %C specifier will read the next character no matter what it is, whether it's a space or even a carriage return. And when you put a space in a scanf format string, the functionality of that is to skip any stream of white space. So you can type a bunch of spaces to your heart's content before you actually say Y or N for yes or no. And so I'm just being safe here in case that happened. In any case, I'll read in the character that you typed into the variable really, and if it's equal to a Y, and of course I'll compare to either uppercase or lowercase, depending on what you type in, I want them both to match, I'll say, wow, congratulations, otherwise I didn't really think you were that old anyway. The special form of if, which is generally called a case statement in other languages, is called switch in C. Basically, you're switching between different values. It's a special form of if that only tests integral values. So basically what you do is you switch on a variable, which is an integer variable, and then you look at each different value that's of interest to you and do whatever you want to do. You have to use the keyword break at the end of each case that you're investigating, otherwise you'll just fall through to the next case. So if you want to keep them separate, which you usually want to do, you always have to use break. The next slide has an example. Just a couple of rules here, things to keep in mind. When you're using a switch statement, it's important that you don't define any variables inside that switch statement. It's a little complicated to explain why at this point, but just keep in mind that when you're inside of a switch, don't declare any variables. There's a special case called default, which will execute in the case that none of the other values that you were interested in matched the value in the variable you were testing. Default doesn't have to go at the end, although it's commonly put there, but it doesn't matter where you put it. You just use it when you need to. Here's a rewrite of the age example from a couple of slides ago using switch instead. This is the type of if-else situation which naturally fits into the switch construct because you're just testing on a set of related values. So instead of using an if, I'll use a switch. And I'm going to switch on age divided by 20. Because if age divided by 20 is 0, that means that age is less than 20 because of integer arithmetic. And likewise, if it's between 20 and 39, then age divided by 20 is 1. So it's really nice to fit in these categories. So whenever you have integers you're testing and they fit nicely into categories, a switch is a nice way to do that. And it's also possible that the code that can be generated by the compiler will be a little more efficient than using if and else. Well, you go through and you can see that
I check age divided by 20, so if it's 0, I'll do what I did before.
I'll print out youth and etc., etc. Notice the break between each case, because what happens is in the switch statement, it always essentially starts at the top and finds the first matching case. And if you don't have a break, for example, if I didn't have one after the printing of the word youth, it would fall through to case 1. Now the exception to that is the default case, as I told you. It will always execute if none of the others match, and it doesn't matter where you put it. I like to put it at the end. It just kind of makes sense so that it parallels the same style if you were using if and else. To support repetition, C has 3 different types of loop: the while loop, the do while, and the for loop. The while loop is the loop that tests its condition first before you decide to execute the statement inside the loop. So the syntax there is while some condition, and it's in parentheses, just like with if statements. Then you execute what's in the loop. The do while is kind of the flip side of that. You always go through the loop once, and then you check the condition. And so for that reason, we even put the statement in between the do and the while. And the for loop, which is similar to other languages, is for counting. It's when you know how many times or for what sequence of values you want to step through a loop. And so there's a nice compact way of expressing that. So we have some examples on the next 3 slides of these different types of loops. To illustrate these loops, I'll be counting from 1 to some number, say n. So the while version might go like this. I'll initialize my loop variable I to 1, and then I'll test the condition up front. I'll say while I is less than or equal to n, and then I'll just print it out and then increment my number. Notice I say I plus equals 1 there. Again, that's that shorthand for incrementing I by 1 or by anything on the right-hand side. But you may recall that there is an increment version, and by using that, I can shorten this example. I don't have to use a compound statement. I can shorten this down to a single statement inside my loop. So the second version, which is the more common way to do it in C, is I'll say printf, my number, comma, I++. So the current value of I will be what is used as the second argument to printf, but as a side effect, I will get incremented. So the effect is the same as the previous version of the loop, but it's more compact, and perhaps more efficient as well. Here's the do-while loop that counts to 10. Since it always goes through the first time before checking, it's going to be slightly different. I'll just go ahead and say printf, my number, and then increment it. And while my number is still within range, I'll go ahead and cycle on the loop. Now, you might be asking yourself, when would I use a while versus when would I use a do-while? And of course, the obvious answer is when you need to step through the loop once first. It's good to note, though, that that rarely happens. Kind of a rule of thumb is that 95% of the time you need a while loop, and 5% of the time you'll do a do-while loop. One example of when you might want to use this do-while is when you actually need to get some keyboard input or other response from the user. So you might have a loop that says, do print a prompt and get a key press, and then the while will say, while it's not a valid input. And you'll just sit there in that loop until the user finally puts in a valid input. Here's a for loop that counts from 1 to n. And a for loop is what you generally want to use when you have a sequence of values like this that's easily delimited with a first one and a last one and some increment value. The 3 parts there in the header there of the for loop are as follows. The first one, I equals 1, is the initialization portion. And you can actually have multiple initialization statements there. You separate them by a comma. For example, you could say I equals 1, comma, j equals 2. Of course, you want to be careful and not have too much clutter in there to keep it readable. The second portion, after the first semicolon, is the condition. So basically, this is a while loop. What the for loop will do is it will do the initialization and then check the condition in the middle there. And if it's true, it will execute the body of the loop. After the loop has been executed, it will execute the iteration portion of the for statement there, which is the last portion, the third part, after the second semicolon. And again, you can have multiple statements there. Notice that I'm using I++. It really wouldn't matter in this case if I had said ++I, because it's a statement all by itself. Whether you do I++ or ++I, when it's independent of any other context, makes no difference whatsoever. And it doesn't really matter. You just take your pick. It's a matter of style, whether you want the pre-increment or the post-increment. Well, now we're going to leave the theoretical part of programming, that is the structured programming theory that says you don't have to do any go-tos or any branching of any kind, and we're going to be practical. Yeah, theoretically you can write a program that doesn't need any branching whatsoever, and it will do whatever you need to do. But to do that, you've got to create all of these Boolean flags to control your loops, and you've got to check them, and sometimes it's clearer in your code just to say, go here. Of course, we want to do that in a controlled fashion. Using goto is something that should rarely be used. But there are some special types of branching that aren't that uncommon. One, for example, is to get out of a loop. Suppose you have a loop, and in the middle of it you say, oops, I'm done. we're out of here. Well, what you want to do is just say so. You want to say, I'm done. I want out of this loop. Well, that's what break does. The semantics of break is it will exit the innermost enclosing loop or switch statement. So if you're in a switch statement, the break will just get you out of the switch statement, not the loop. And that's actually a reason for using a go-to. If you have a switch inside of a loop and all of a sudden you want to get all the way out of that loop, well, a break won't do it because a break will exit the switch if you're in one. But if you're not inside of a switch and you're just inside of a loop, then the break is just what you want. It'll get out of that loop and go to the next statement after your loop. Continue is borrowed from Fortran. What that does is it cycles on a loop. So if you're in the middle of a loop and you say, oh, I don't really need to execute the rest of these statements, I just want to iterate on my loop, well, continue will do that. And what it will do is it will go to the test for that loop and perform it, and if it's supposed to keep going, it'll keep going just like normal. Well, for those cases where you do need to do something unusual, like the case I just mentioned of a switch within a loop, then you do have a go-to. And the way that works is you have to put a label in your program. A label is just an identifier, like a variable, followed by a colon. And later on, when you need to go to that point, you just say go to and then the name of that identifier without the colon. And it goes right there. Now, I'm not going to show you an example of that because, of course, well, we're supposed to discourage use of goto. And as I said, in Java, it doesn't even exist. And so I'm not going to say anything more about goto. But there is an example of break and continue with loops on the next slide. In this program, I'm going to go through a list of integers and look for the first integer that is odd and its digits sum to 7. Kind of a contrived example, I'll admit, but it gets the point across of how to use continue and how to use break. If you'll take a look at that list, which is the first line in the beginning of the main function, I'm using an array, so, yes, we haven't talked about arrays yet, but I think you can get the idea here. I have an array of integers, 10, 21, 32, 43, and 54. If you look through that, you can see that the odd number whose digits add to 7 is 43. For simplicity, I'm just going to assume that the numbers have 2 digits. The program would be a little bit more complicated if that wasn't the case, and it wouldn't fit on a slide. So, here's how it works. I'm going to have a for loop that goes through each element in that array. Since it's one of those things where I know how many there are, a for loop is the natural thing to do. Then I'll have a couple of variables for the digits, but before I even peel off those digits and put them into those variables, I will ask if the number is odd or even. If it's even, I'm not interested in it. So I just want to skip the rest of the loop, and that's what continue does. So if num sub I mod 2 is 0, then I just want to cycle on the loop. So the continue statement will do exactly that. It will ignore the rest of the loop and return to the iteration portion up there, the ++i, and do that, and then it'll do the test for the next iteration, just like it normally does. Well, if that's not the case, then I'll fall through and look at this odd number. So I will peel off the rightmost digit by taking that number mod 10. Whatever's left is the right digit. And the digit to the left will be that number divided by 10. Keep in mind, this only works for a 2-digit number. And then I'll just do the test. If digit 1 plus digit 2 is 7, well, then I'm done. There's no reason to continue with this loop. So I will say break after I print out that I found it, and then I'm finished. Since all algorithms can be expressed in terms of just statements and decision-making and loops, then that's what you should do most of the time. And C, of course, supports that very well with its different types of loop and if and else, and switch when it makes sense to use it. But sometimes you do need to branch, to break out of a loop, or to cycle on a loop, and so those are there as well. And as a reminder, most of the loops you'll ever use will be of the while variety, that is, they will test first before they execute the body, and that's what while and for do. As an exercise, I'd like you to rewrite the even-odd summing program from the previous section where you read a number and test it whether it's odd or even and accumulate it. By making the change that you can process any number of integers, whereas we only did 3 last time, now you can loop. You can loop forever if you want, and then just keep going until you hit some value. Now, one thing I didn't show you is that a repeat forever is easily done with either a while or a for.
For example, you can say while 1,
because 1 is true, or you can use any non-zero value there. And then that loop will go forever, and then you'll want to break out of it in the middle. Another way to do that, and it's actually the more common way, is to have an empty for loop, that is an empty header in your for statement. You'll say for, and then inside parentheses, just 2 semicolons. And so that is a repeat forever construct as well. So what you can do is just have a loop like that, and then read from the keyboard and test it, whether it's even or odd, and keep your sum. And instead of just using the if and else in there, why don't you use the switch on 0 and 1 to see if the number is even or odd.